Hello, welcome to Meteorology. In week 1, we are going to kind of go through some basics in what meteorology is. And in this video specifically, we're going to talk about these first two items here. What is meteorology? And then we'll talk about what meteorology includes and how it works. And then in video 2, we'll talk about the structure of the Earth's atmosphere. And then in video 3, we'll get into how the atmosphere produces weather, along with how we monitor the production of that weather. And then we'll talk about what the 7 major weather elements are. So, what is meteorology? Some of you will remember this question if you've already done your Introduce Yourself discussion forum. Meteorology is actually the study of the atmosphere. Some people confuse the study of meteorology with the study of meteorites and what's happening out in space. That's actually what's called astronomy. So meteorology includes the atmosphere and phenomena that is produced in the atmosphere, such as clouds, rain, snow, hail, thunder, hurricanes, so on and so forth. Basically weather. So it's the study of the weather that we see outside. And weather can be defined by the current state of the atmosphere, so it's happening now outside. And then climate, which is another part of meteorology, which is the state of the atmosphere over an extended period of time. So one example of climate would be looking at the weather of occurrences, temperature changes in Hood River over a 10, 20, 30, 100-year time span, whereas the study of weather is just looking at what's happening in the shorter time scale, so in the maybe last week or month type of thing. And meteorology is one of the 3 major earth sciences: oceanography, geology, meteorology, and some people throw astronomy in there too, or the study of outer space. So what are the main ideas in meteorology? Well, one major thing, if you'll remember from other science classes, that the Earth is a system. So it's constantly changing, it's composed of interacting parts, it's closed in regards to matter and open in regards to energy. So the interacting parts the Earth has are 4 different spheres: the lithosphere, the biosphere, the hydrosphere, and the atmosphere. Lithosphere would be the rocks, biosphere, life, hydrosphere, water, and the atmosphere, the air, which is what we are going to focus mostly on in this course, with a little bit of the hydrosphere mixed in as well. Another important, 2 important items in regards to the Earth is how the Earth is closed and open. So the Earth is actually closed in regards to matter, so we don't get huge quantities of mass entering the Earth or leaving the Earth. Yes, we have some asteroids, meteorites, whatever, that come into the Earth, but it's such a small percentage, small volume, that it really doesn't count. But we are open in regards to energy, and this is a major factor, and we're going to talk about the Earth and energy and production of weather in great detail next week. So we get energy reaching the Earth in the form of radiation from the sun, and very important for the production of weather. If we didn't have this incoming solar radiation, we wouldn't have the weather that you see outside throughout the year. So very important, but we'll come back to that. Why is meteorology important? Why do we care, basically? Well, it's important for storm prediction, so you know if you should bring a raincoat with you when you go to work, or if there's some more severe weather, such as hurricanes, tornadoes, ice storms like we had this winter. It's important for farming and precipitation, so we know, okay, should we irrigate, should we not, so on and so forth. And then also the importance of climate and climate change, and also knowing how things have changed over time so that we can prepare for the future changes that will occur. So some other parts, so I mentioned before, the Earth subsystem, the atmosphere, is what we're going to be focusing on. In this little diagram, you can see a cloud forming over a mountain range. That is where we are going to focus most of our time, and kind of the interaction of the atmosphere with the hydrosphere and a little bit of the lithosphere as well. So what does meteorology include? What are the main parts of this subject? Well, we include observations, so watching the weather that we have outside that are occurring, taking measurements, recording the data, temperatures, so on and so forth. There's also a section called atmospheric physics. This is where scientists take that data that's been collected and they use it in different models and experiments to be able to predict what's going to happen in the future as far as weather forecasting goes, and it's the next category. So it's taking those models and experiments and actually trying to use those models to predict how the weather might change over time. And then the study of climatology, which is analyzing the climate over time and maybe trying to predict what might happen in the future. So all of these major sections we're actually going to go through and talk mostly about weather observations and the different weather elements, get into the details of those, and then we'll talk about weather forecasting and climatology. We'll talk a little bit about modeling, but not in great detail. It's for a higher level course. So in all of these different sections or parts of meteorology, we're going to use the scientific method. And basically, you guys are going to be doing this in a small variation in lab each week, and then you're also going to be collecting data throughout the entire term about the weather that you see outside campus. We're going to look at forecast models, and then you're going to compile all this information throughout the term, look at it, and see what kind of findings you have. What can you say from that data that you collected? So in the scientific method, make observations. You're going to make some weather observations outside. Might come up with a question, maybe the question that we're going to be evaluating and comparing our forecasts that we might use to predict the weather for the following week, and then compare what actually happened. So are those forecasts really good, reliable forecasts to use? You're going to come up with a hypothesis, might do some experiments. So you're going to be collecting data, sampling the temperature, humidity each week, and then you're going to maybe reevaluate your hypothesis. Maybe it's not working right. Maybe you want to do something else, and then you're going to figure out what exactly your final conclusion is, and you're going to communicate those findings. And for us, we're just going to communicate with each other in class. If you're in the scientific community, a lot of scientists will go to meetings and give presentations, publish papers, things like that. And then sometimes reevaluation needs to happen. So if I go to one of these major conferences, people give talks, and you might find a lot of people questioning different data, and then scientists will then go and they might kind of reevaluate how can they make their findings a little bit stronger, so they aren't quite as questioned. So that's kind of the gist of meteorology. So what it is, what it includes. We'll come back in the next video and talk more about the atmosphere.